Welcome, or hopefully welcome back to another episode of Reliability Matters, the podcast where we dive deep into what it takes to build reliable electronic assemblies. On this episode, we're diving into a deceptively simple but incredibly important topic, humidity and the massive impact it can have on electronic assembly reliability. Joining me is Viktoria Rawinski, a seasoned expert in material science and reliability engineering, whose career spans decades of hands-on experience in failure analysis, process optimization, and design for reliability practices. Viktoria is not only a respected voice in the industry, but also a passionate educator, known for breaking down complex technical issues into actionable insights. In her two-part LinkedIn series, Humidity, a small cause with a huge effect, Viktoria explores how environmental moisture, often overlooked or underestimated, can trigger serious failure mechanisms in circuit assemblies, especially as devices become smaller and more complex. From solder mask absorption to electrochemical migration, we'll unpack the hidden risks that can jeopardize product performance and long-term reliability. Whether you're in design, manufacturing, or quality assurance, this is a conversation you won't want to miss. Let's get started.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, Viktoria. Thanks for joining me today.
Hi, Mike. Thanks for having me here. I am really excited and proud to join you to your podcast.
Oh, thank you. I'm honored that you're here, and I'm excited to talk to you. We usually see each other at conferences. We speak at a lot of the same conferences around the world, and it's always good to run into you in person. And the next best thing is to see you in pixel form. So there we go. Before we get started, before we dive down the technical rabbit hole, I want to make a couple of comments on your recent activity on LinkedIn. You have been posting tons and tons of technical content daily. Tell me what that's about. That it's really good, and it's on so many different subjects. For example, one of them was Step Aside for the Dendrite Queen, where you had yourself talking about dendrites and electrochemical migration, and the image was you with dendrites growing out of your head. You talk about, of course, moisture in PCBs, which we're going to be talking about today. What spiders have in common with silicone. I mean, there's just some really interesting topics. So tell me about your kind of self-imposed challenge to post every day for so many days. What's that about?
I hope that the people can understand very technical things in an easy way. So I try to explain every day a little bit from the large complex system so that's maybe more easy to understand what's cross-linking like. Cross-linking is like like a spider web.
Yeah, so there's a connection
something
between...
like dendrite queen, it's like a nightmare. And you need also the humidity factor for this, because without the humidity, you wouldn't have dendrite.
Yeah. Oh, everything's all connected. It's a series of dominoes all stacked up, and you push one and all the rest fall over, right? Or you remove
Small
one and things stop.
Huge effect.
Exactly. You posted recently that you've been posting technical content daily for the last 28 days, and you have over 87,000 views. That's amazing.
I don't know. I don't care about the views.
Yeah, but
also I don't care about the likes.
Yeah, I'm the same way with view count. What it does tell me is that it's becoming it's engaging. It's engaging people, right? That's all I need to know when I do this show. I don't care if there's 80,000 or 1,000 downloads on the show. What I care about is that there are downloads of the show, right? That we're impacting people, and
I follow you on LinkedIn, Mike.
Oh, yeah. So, it's just post.
Yes.
So I don't know. I think between your posts and my posts, there's no room for anyone on LinkedIn. We're full. I don't know how they handle all the bandwidth. All right. Let's talk about the subject at hand, which is, I find, an extremely interesting topic. I talk on this subject all the time in terms of narrowcasting, meaning I talk about humidity a lot, but in the context of how it impacts reliability through electrochemical migration. And I know it's got a much wider footprint than just that. So when I read your two-part article on LinkedIn about humidity, it really, I'm like, yes, someone else gets it. Yes, exactly.
Yes.
So I want to kind of dig into that from your perspective, which is a broader perspective than mine. Let's start with the big picture. Speaking of broader perspective, why is humidity such a critical yet often underestimated factor in electronics manufacturing?
Because you cannot see it really. You have two kinds of humidity. The first kind of humidity is a physically bound humidity inside the solder mask. And this humidity you can try. It is included in the small holes, microscopic small holes. If you dry the product, you can put the humidity away. And the second kind of humidity is more dangerous because this is chemically bound humidity. So water molecules are included in a three-dimensional cross-linking structure of the PCB substrate and also solder mask. And because it's chemically bound, you cannot dry it anymore. So if I perform some FTIR spectroscopy, I see humidity in the spectrum, but I also see if the humidity is chemically or physically bound. And what the supplier of the PCBs or manufacturer of the PCBs, especially from East Asia, try to cover up is if the storage is not right, not done in the right way, they try to dry it up to the dead end. So and cause thermal degradation in the product. And you can also not see the thermal degradation just by your eyes. So, and thermal degradation results in dendrite and electromigration later.
Is there a similarity, or is there a connection between this cross-linked phenomenon and hygroscopic materials, which attract water? Are they one and the same, or are they two different phenomenons?
It's you cannot divide it. It's how to explain. Is a cross-linking effect of the PCB substrate, for example, is if you have some large molecules and they link to each other. And the more tight the spider web is, the better the material protects against the humidity penetration.
Right. So we have two issues here. We have materials that, because of the large molecules bonded, gripping onto each other as hard as possible, we can't completely remove the moisture from that. We can't dry it completely. And then we have, on the other side of the coin, we have materials that are starving for moisture, that are trying to absorb as much moisture, like super sponges, right? They're trying to absorb as much moisture as possible.
You can see this effect, for example, in the fillers of the solder mask. If you have some the smaller the particles of the filler from the solder mask are, the less is the moisture absorption.
So are there, as far as board fabrication is concerned, are there certain types of solder mask that should be avoided, either because of maybe a hygroscopic nature or this cross-link, condition where it'll never dry out? Are there better masks than others as far as that's concerned?
Yes, the PCB manufacturer can do a lot of mistakes by manufacturing the PCB. So What the PCB manufacturer tried to do is to shorten the process times, because the process times are really expensive.
Sure.
If I try to shorten this by, for example, by addition of too much photoinitiator molecules, which initiates the photopolymerization, I can shorten the time in which the small acrylic molecule can grow to the larger molecules by addition, by adding of more polymer photoinitiator. But if I shorten the time, the molecules of the solder mask cannot grow to a long chains, and they keep to stay short and cross-link afterwards. If I have shorter molecule chains in the solder mask and I have thermal effects or humidity penetration or some thermal cycles, they will break. And when they break, they leave holes and let the humidity to go so much more easier inside.
Interesting.
The second effect what PCB manufacturer do is to keep more cross-linker inside the PCB substrate. So the resin can be pressed, so the pressing process can be performed so much faster, but you have additional cross-linking agents inside between the layers, and they can cause electromigration along the glass fiber, for example. If the humidity penetrates by the incompletely cross-linked or chemically finished reaction of the solder mask itself. So I have a lot of cases which from my customers with product recalls, which is really expensive.
Yeah, I'll bet.
I never stopped to learn.
Yeah, me neither. In your article, you mentioned that relative humidity affects not just corrosion, but also ion mobility and electrochemical reactions. Can you walk us through us meaning myself and my audience, through the science behind that?
The humidity inside the material can inhibit chemical reactions by manufacturing process in a first step. So if we have something like photoinitiation of the solder mask, and the molecule of the photoinitiator is splitted into two halves by UV radiation. If we have humidity, the oxygen from humidity just catches the reactive part of the photoinitiator and inhibit in this way the photopolymerization reaction. So you have still the photoinitiator inside the solder mask, but you cannot complete this reaction by influence of humidity. And the same or very similar process is by cross-linking process of the PCB substrate, so the layers inside the PCB. Also, the cross-linker try to connect the resin molecules, but if you have a presence of humidity inside, oxygen is very reactive in the same way like the cross-linker is. So the oxygen also catches the cross-linker, and you have incompletely cured PCB layers. So the PCB, the finalized, finished PCB is failed.
Interesting. There was a issue. There is an issue. A little less common today, but still, I see it regularly. Of someone will test a board after cleaning in a rose tester, in a resistivity of solvent extract tester that uses IPA and DI water as an extraction solution. And when the board is removed, and that, by the way, it's not just in a rose tester. I've seen it in cleaning machines too. When the board comes out the other side, it's got a white haze on it.
Patchy appearance, yes.
Yeah, but you can't remove it. You can scrub it all day long, and it doesn't come off. And it turns out, from what I understand, it's basically the result of a improperly cured solder mask. And And one way to get rid of that white residue, which is benign, by the way, but is to bake the board. So that tells me that's a moisture issue, that
Yes.
mask is absorbing moisture and reacting in terms of this white haze. And that to me was, in the cleaning world, an anecdotal piece of evidence that solder mask can indeed attract and hold on to moisture. Am I connecting the dots properly? That is part of what we are talking about here, the moisture-induced residue.
The problem of patchy appearance after cleaning, especially, has a root cause in an incompletely polymerized and cross-linked solder mask. So if the molecules couldn't react completely chemically, you have some how to say, incompletely reacted areas on the top of the PCB, and so areas which are chemically happy and areas which are
chemically happy. I love that. We want to make sure our fabricators
don't need anything. Yes, just
we have to put it into
happy.
We need to put in the statement of work that the molecules in the mask have to be chemically happy. That's yes. I love it. That's the new standard.
And the next area next to this area is maybe area with incompletely photopolymerization or incompletely cross-linked molecules in the solder mask. So if you put the PCB after, you cannot see it before soldering. You can smell it. So if you, the smell is very strong. So the odor is very strong of PCB with incompletely finished chemical reactions. What happens after soldering by cleaning the product? You put it in the cleaning machine, and the cleaning agent goes inside and grab the reactive parts of the solder mask from unhappy areas and wash them away. So it is a chemical process. But I also saw some effect from one of the customers after soldering. So the flux had started some reaction with an incompletely cross-linked solder mask because the manufacturer of the PCB shortened the process of curing. So the final process of curing where the solder mask can cross-link. And incompletely cross-linked solder mask got the heat by wave soldering process and polymerized and cross-linked together with flux. So there is no way to clean it anymore.
Interesting.
Because it's a mixture.
Yeah. What are some of the common misperceptions manufacturers have when it comes to ambient humidity and its role in reliability?
Some manufacturers just ignore the rules of chemistry and physics.
Doesn't apply to me. It doesn't apply to me, right?
They shorten what you cannot shorten. The processes cannot be optimized to the end. So you need time for growing from acrylic molecule, for example, for growing. So if you shorten it too strong, then you will have just short molecules. And if you have short molecule chains, you will have later cracks in the solder mask and also impurities, flux, and other residues. Also, humidity can penetrate without any barrier. So,
yeah, one thing that I've discovered is a lot of manufacturers will feel like, well, we don't care too much about humidity because our product is going into a controlled environment. It's not going outside. It's not going in an unpressurized part of an aircraft. It's not going into space. It's not, of course, not a lot of humidity in space, but it's not going into, down an oil well in Houston or on a oil platform. But in a case, a pretty well publicized case, a lawsuit for Microsoft. They built the game console, the Xbox 360.
Yes.
And several years ago, they had to recall thousands and thousands of, or maybe even millions, I'm not sure the exact number, of units because they had an ECM issue created by humidity. Although, when you think about where are these consoles living, they're living in people's bedrooms and living rooms, and generally speaking, unless you're in a grass hut in Tahiti somewhere, there's not a lot of humidity inside a controlled environment like a home, with air conditioning and heaters and things like that. So it turned out that the problem was improper thermal management. And when the manufacturers employ thermal management, their primary goal is to keep certain things from overheating, right? In this case, it wasn't that something overheated. It was that all the technology they put in to ensure that certain components would not overheat actually created a rapid cool down effect after the console was turned off. And things cooled down too quickly, which created a little microclimate within the boundary area, within the boundary layer of the air touching the assembly and the air in the enclosure. And
unbelievable.
Yeah, and it caused the air temperature in the boundary layer to cool down too rapidly. And of course, cold air can hold less moisture than warm air.
Yes.
And it created a dew effect, basically. So it condensed onto the board, which in the moment wasn't a problem because the board was turned off. But a few hours later, someone turns it back on, the board is still wet from condensation, and voila, an ECM event took place. And it was one of the most expensive consumer product recalls in history. It was more than $1 billion with a B. And it had to do with basically they created their own harsh environment within an enclosure which was located in a stable environment, not harsh environment. So the rules apply. You mentioned earlier some people think the rules don't apply to them. Well, all the rules, physics are physics, science is science. It's very consistent. And that consistency showed itself in that little razor-thin boundary layer, very small bit of air. That's all it took. That, to me, just illustrates one of the misconceptions that some manufacturers can have in terms of what is a harsh environment, what isn't a harsh environment, and what isn't a harsh environment can become a harsh environment under the right conditions.
Exactly.
Right? So I think that's really a factor that many manufacturers need to consider is, what is thermal management? What is a harsh environment? How do the two interlace and affect each other?
I just wanted to tell something about one of my customers, which he has some electromigration, very small traces of electromigration, and the board was covered by a protective layer, and the electromigration was on the surface between the solder mask and the protective coating. And by analyzing that, I saw some traces of sea salt from the ocean, and I asked them, what happens?
Talk about a harsh environment.
Yes. So the manufacturer of the PCB had some issue with air conditioner and just opened the doors on the coast after the PCB manufacturing. So traces of sea salt and product recall afterwards. Also very expensive.
Yeah, I love boating. I love being on a boat, and one of my first boats was an ocean boat, and I would take it out to the ocean, every weekend that I could. And the moment I got home, I had to wash that thing down with soap and water just to get all the salt off it, and I had to flush out the engine because the engine is water cooled and that's salt water, and those engines all had an anode attached to the basically a sacrificial piece of metal attached to the engine, because in salt water, the salt water wants to basically it's a great electrolyte. There's electrical
Yes.
systems on the boat, and it just wants to eat the metal, for lunch. And so you give it something to eat that's easier to eat than the rest of your boat. But that's the worst of the harsh conditions, because it's not just salty air; it's salty water, and you're in it. But it does show the power of corrosion when it comes
Yes,
to
exactly.
not just water, but in that case, salty water. How does humidity exacerbate electrochemical migration, particularly as it's related to miniaturization? We are making boards much denser than we used to be. Components are much closer to the board than they used to be. Cathodes and anodes are microscopically spaced apart from each other. And we still have, ECM. ECM can work on, pretty much any level, given enough current and given enough, electrolyte
Yes.
and all that. What have you seen? How have you seen miniaturization affect the tolerance for harsh conditions, particularly humidity?
It depends on the condition where the board is finally used. I had one customer from automotive, and with a very large board, with very large components. All of them were covered by protective coating, but one area with very, very small resistance, size like this, couldn't be covered. And over very small paths, maybe 5 millimeter, maybe less, from component to component, the dendrite could grow very, very fast. So it's maybe wouldn't be that dangerous if the board would not be used in automotive sector, but in this special case, it also results in product recall because of one small component.
Yeah, interesting. Are there certain board designs or layouts? I mean, other than put things farther apart,
Yes.
triple the size of your board and reduce by half the number of components on it. Outside of that,
But I think it's an issue of time. If you reduce the humidity and you enlarge your paths and the way from component to component, you will also get electromigration. It's just a question of time.
right, right, yeah. I used to when I was in auto shop in school. It was I learned to be wanted to be a mechanic when I was younger, so I learned all about cars. And one of the things that we would do back in my day, in the 1960s, well, this would be 70s by the time I was in high school, there was still a lot of metal on cars. The dashboard was made of steel, and of course, lots of bumpers and metal things on the car. We would send them out to be chrome plated because we thought chrome was cool, right? Nice and shiny. And
Yes,
so anything that was painted a regular color, we'd strip the paint off and send it out to the plating shop and have it chrome plated. It was obnoxious. But I remember going to the place that did the chrome plating because I'm like, how does that work? And of course it's it's electrochemical process, and it's a whole plating operation, and it's basically just a giant bath of solution, a piece of metal on one side, your part on the other side, and current running through it. And of course, the metal dissolves and migrates through the electrolyte and attaches itself to the donor.
Electroplating, yes.
To the other side, right? It's electroplating. But these things were this far. I mean, they were quite a distance apart. They weren't anywhere near the distances that we see on circuit boards today. These were large tanks. An entire bumper could go in there, right? So they were many meters apart. And so I've always understood that metal can migrate great distances. And in that context, I see that in our application, metal does not have to migrate very far at all. It's just a few molecules in distance, of width, and you're pretty much halfway there. So I can see that density and spacing plays a role, although it doesn't guarantee you can eliminate it. It could delay it. It could run out of source material before it reaches the other side. But are there other design characteristics or material choices that can reduce the impact of moisture on circuit assemblies?
I don't think you can really reduce the impact of moisture, but what you can reduce is the degree of cleanliness on the PCB substrate, on the solder mask itself. I see from time to time, we are talking about electroplating agents, I see on the surface of the solder mask traces of electroplating agents from the metallization processes from the PCB manufacturing itself, and you need so much less humidity to cause the electromigration in this way, for example, as if you have an absolutely clean solder mask surface.
So one of the kind of knee-jerk reflex moves manufacturers will make, is they'll conformal coat the boards to protect it against harsh environments. And conformal coating is definitely a good strategy to protect against harsh environments.
If the surface underneath is clean.
Assuming
if not, you have a serious problem.
if not, yes. Okay, let's start there. I was going to go there, but I'm glad you brought that up. Let's assume that one has conformally coated the boards over a dirty board. And let's assume that the board was clean enough that it didn't cause delamination of the coating. That's the number one concern, really, when someone coats over residue, it doesn't bond properly and then it delaminates. But let's assume it's stuck. I was hired as an expert witness for two companies that were suing each other. The lawyer hired me and a few other people to help them with the case. And it turned out that this manufacturer built a board that was going to be potted in silicone and encased in a fairly decent enclosure and buried in the ground. It was a sensor. And the board, because there was no power line in the ground, the board would operate off a battery that was supposed to last 10 years. And you can guess what happened. After about 3 months, the batteries were drained, and the company had to recall thousands of units. They had to go out into the field and dig them up and replace them, and they didn't understand what the problem was. And what they did, their strategy was, look, these are going to go into the ground. The ground is a harsh world and harsh environment. We don't want things, anything from, rodents to bugs to chemicals, whatever, moisture to ingress into the part. So we're going to pot it in 2 inches of silicone all the way around. Okay, that's reasonable. What they didn't do was clean the boards properly. They didn't bake the boards prior to potting at all. They cleaned the boards with just water, even though there were polar or non-polar residues on it. So all the non-polar stuff stayed. And all, it was just mistake, or worst practice. And then they potted it, thinking that was enough. And what they actually did is they did the reverse of their intention. Instead of keeping the bad stuff from coming in, they entrapped all the bad stuff. Yes, they took all the criminals, all the bad actors, put them in one cell, and ensured they could never get out. And they just rioted. They had a riot on the board. So we had ECM on the surface, we had dendritic growth, we had parasitic electrical leakage, we had CAF, conductive anodic filament, which is basically, ECM within the layers of the board. They had corrosion, you name it. It was a poster child of all the things that moisture can do. And it's because they trapped it all in the assembly, and it had nowhere to outgas because it couldn't get through 2 inches of silicone. So that was certainly an example of a bad design, right? And good intentions gone wrong. So let's talk about conformal coating. In whether it's acrylic or a silicone or parylene or anything in between, I think a lot of manufacturers don't realize that no conformal coating is truly moisture proof. It is moisture resistant, right? Correct me if I'm wrong. Conformal coatings are permeable to some degree. Am I correct?
Yes, that's true. And also one of the large mistakes is if I put conformal coating just on the one side and don't put it on the other side, humidity can penetrate from the side, and the product will also fail.
Yeah, we've seen. In fact, we have photographs. We published photographs of dendrites growing under conformal coating.
Yes, I see it a lot of times.
Yeah, so that because dendritic growth requires moisture as an electrolyte. Without the moisture, it couldn't grow. So just the evidence of the dendrite is also evidence. It's the smoking gun. It's the evidence that there's moisture there.
Yes.
And assuming the board was properly baked before coating, which is best practice, that moisture was introduced to the board after coating. And I think coating does buy you time. It does slow down the infusion of moisture, the ingress of moisture, but it ultimately won't prevent it 100%. It will reduce it and slow it down.
It should be completely cured. So conformal coating should be chemically happy.
Chemically happy, yes, exactly.
Yes.
Exactly. See, we want more happy things on our boards. For manufacturers operating in various varying climates, from the desert to the sea, what advice would you have when it comes to setting up environmental controls or quality protocols? Well, if you were building a board and that board was designed to keep you alive, it can't fail, or something bad happens to Viktoria, what measures would you employ in the design and in the fabrication materials and in the use of how that board is deployed? Build me the perfect board.
IPC gives good recommendations and rules what to do in these cases. But the first thing I would do is to keep to monitor every step I do and to keep the manufacturing environment very, very clean, strictly clean, to make sure that every chemical reaction in the PCB manufacturing process is completed. And also keep a very close view to the design rules. If I have, for example, paths on the PCB surface with a distance of maybe 100 micrometers, and I have cavities in between in the solder mask, which are 90 micrometers, this product will fail in every case.
Do you think the industry pays enough attention to material selection, like the choice of solder mask resin or laminate in terms of moisture management? Or do we just, call up our board broker and order the cheapest board that we can that
That's
meets
my
the minimum
experience.
standards?
Yes, I wouldn't say meet the minimum standards, but the problem is that people don't understand the issue. Also, worse quality of the PCB look green and shiny on the surface. And for example, if you have traces of solder mask over the solder pads, finally, very thin covered, you cannot see it. It looks beautiful, and you can print this board. You can perform any electrical test because the needle goes on the surface, press the solder mask, thin film just away, and you will get a beautiful electrical contact. And you can print this board, but you cannot solder it. You will get solder bead formation and a very horrible result. And nobody knows what the reason is. They perform some micro sections and intermetallic investigations, but the reason is in more than 95% solder mask film over the solder pads.
Interesting. And from every other measurement, it looks great.
Yes.
Except one small detail. You can't solder it. But other than that, it's great.
But if you don't know it, you don't mention it. So
Yeah. If you had the power to rewrite one or more industry guidelines, if it could be IPC J standard Victoria, right? What regarding humidity control and all of that, what would you add or change to the current conventional wisdom, the current thinking, the current standards in terms of humidity control and all the knock-on effects?
I would start with more education and more understanding a process that the people know what they're dealing with before they just follow the regulations. Because if I exactly know what can humidity cause more than just dendrites, so unhappy chemical reactions, for example, or in a final result, covering of solder mask over the solder pads, because the humidity inhibited something in the step before. If I know all of these things, I can work very happy with established regulations. But if I don't, I just follow the rules.
Very good. Any parting thoughts? We're about out of time. Any parting thoughts you'd like my audience to hear or know from you regarding humidity and humidity control and all the nasty things that occur when moisture gets involved?
Yes, the first thing I would like to share with the audience is if you open the moisture barrier and back and you put the PCBs, the unpopulated PCBs out, just smell. You can detect the worst quality in a very easy and affordable way just within seconds. And if a smell very strong, unusual strong, you have incompletely chemical reactions in your product, and that can lead to product failure later.
So if it smells like a chemical factory,
yes,
that's interesting. I don't think that has ever made it to a standard, the smell test, right? But I guess you should not smell anything, right? There should be like no specific odor coming from it.
Yes.
If it smells like it was...
If you smell something, the gaseous molecules are not in the PCB anymore. They are already in your nose.
Yeah. Interesting. That's a good hack, right? It's one of those things that are not printed anywhere, but it's a very tribal, valuable piece of knowledge. So you heard it here first, audience. Go back when you're done watching this show or listening to this show, leave your tech bench, head over to the production floor, pick up a board, hold it up to your face, and give it the smell test. If there's no smell there, continue on. If there is,
yes,
maybe it's time to call your board vendor or reach out to Viktoria. And if you wanted to find out more about Viktoria, I'll put the links to her LinkedIn profile in the show notes. So if you're watching this on, there you go. If you're watching this on YouTube, down here somewhere, it says see more. Just look down there and you'll find out how to follow Viktoria and be one of her legions of followers that are on LinkedIn. And if you're listening to this on your favorite podcast app, when it's safe to do so, go to your podcast app, look at the show notes, and Viktoria's information will be there as well. Viktoria, I think you're coming out to Surface Mount Technology International in Chicago in the fall.
Yes, most of my favorite events every year. I highly recommend this for everyone.
Yes, I enjoy SMTAI a lot. And I also see you every year at PanPack in Hawaii.
Yes.
and I think the only reason you go to Hawaii is to study the effects of humidity, because there's lots of humidity in Hawaii,
yes.
Right? So
I learned something very useful. Flash flooding from this year.
Yes.
Flash flooding is, it was raining like this.
Yes, we had the last day of the event. We had some, like a monsoon come through, right? And
yes.
Yeah.
A lot of humidity.
Well, the benefit of that is the last day of any conference is not attended as well as the first, second, third day. PanPack goes for 4 days. So day number 4, if you're a speaker on day number 4, I always feel bad for the speaker on day number 4 because there's not as many people in the audience because they're all catching flights or they're surfing or whatever they're doing. We had a full house on the last day. Why? A, the speakers were very interesting and the topics were useful. Or B, there was nothing to do outside because the rain was going sideways, right? So maybe a little bit of both. Maybe a little bit of both. But it was well attended day number 4 at PanPack. Viktoria, I'll look forward to seeing you in Chicago in a very short period of time, and we'll catch up. And in the meantime, again, check out the show notes, get information on Viktoria, follow her on LinkedIn, and you'll learn something every day. Absolutely every day. Thanks, Viktoria, for being my guest. I truly appreciate your knowledge and your willingness and enthusiasm to share it with the industry.
Thank you.
And that's a wrap on another episode of Reliability Matters. Thanks for hanging out. Whether you listened to it on your favorite podcast app or watched it on YouTube, I really appreciate you being here. If you haven't already, hit that subscribe button so you don't miss future episodes. Are you on YouTube? Give it a thumbs up and subscribe so you'll know when new episodes go live. New shows drop every second and fourth Tuesday of the month, so mark your calendars. A big thanks to PCB Chat from the Printed Circuit Engineering Association at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@mikeconrad.com. That's Conrad with a K. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.